Aye, passengers. Do you have a ticket for today's cruise? Okay, I'm gonna stop that. I think I'm the lousiest captain ever on a ship. So I'd like to welcome you back at EMW's Filter Campus channel. And today we have a special mission. We have a mission of a customer to find the treasure when it comes to gas turbine performance. And therefore we have a special guest today. Here he is, Charlie. Charlie has a lot of background information about this project, and I would say let's have a first look into the project site. That's not a paradise at all. I mean, you have a beach site over here, but the gas turbine instead is directly at the port, surrounded by industrial area, huge pollution, and on top of that high humidity all over the year, and of course also the influence of salt in the air. So that was the circumstances or the troublesome background of that project, and I would say in the first step let's have a look at the initial filter setup in their filter house system. Yes, perfect. This graphic shows us pretty much that we have a two-stage filter system. Each stage is on a separate filter wall. You can see that we have total 2 filter walls available, and the pocket filters on the first filter wall, the pre-filters, refer to a filter class called G4 according to the old test standard EN779. And on the second filter wall we can see the final filter or the compact filter in the filter class F9, also according to the old, not anymore valid test standard EN779. Very important information for you is that the old filter system which you see over here had problems specifically on the pre-filter side. That means the pocket filters hardly reached the service life of 1 year, and accordingly the operator had to stop the unit during an unscheduled outage. That means they had to change the filters and stop the machinery which they hadn't planned before that. And there's Charlie with a very important question.
How does the gas turbine perform?
Thank you, Charlie. So let's have a look on the compressor efficiency. Thanks again, Charlie. Here we have a chart about the compressor efficiency. With the old filter system during an operation time of 8,000 hours, we could see that we have a very unstable compressor efficiency trend. We can say that within 4,000 hours we had a drop of around about 2%. And then the operator tried by washing the machinery offline to gain back the output level, but you can see that the compressor efficiency had a boost back, but then within the next 6 months, means 4,000 hours approximately, they had another drop of approximately 2%. So, and now we jump to EMW's upgrade, and then we can see how we established the stabilization of the compressor efficiency. We are back in the filter house, and we can see we still talk about 2 filter stages on 2 separate filter walls, but what you can see is that we added another filter on the second filter wall. But let's start with the final filter, which is the most important one. Still a compact GT filter, but now in the filter class T11 according to the new test standard ISO 29461. That means we had a huge jump when it comes to filtration efficiency, when it comes to better air quality for the gas turbine. On the reverse flow mode, we can see on the same filter wall we have another compact filter established in the filter class T8 according to ISO 29461. And on the first filter stage it looks like we still have a pre-filter pocket filter design, but what I can tell you is this is a pocket filter made for gas turbine applications on coastal areas. So we have a triple media layer included, so it's not a standard pocket filter, it's quite a special version for gas turbine application. So ladies and gentlemen, and now we're gonna get to the highlight of this story. Let's check out where is the treasure. Therefore we have the following chart. Yes, this is the treasure, and now I'm gonna explain you what is it all about. You can see 2 columns on the left hand side. This represents the results with the original filter system. Right hand side the results of EMW's filter upgrade. And let's have a focus first on the area here represented in orange. This shows power degradation caused by compressor fouling. And you can see EMW's upgrade significantly reduced the costs which you had occurred due to compressor fouling, significantly. Now we have a look at the areas here in purple, which shows us the impact of pressure drop levels on the power degradation of a gas turbine. And of course, the more efficient filter system of EMW occurs in higher pressure drop initially, which then of course has an impact on the performance of the machinery. But the savings achieved due to better air quality provided to the machinery means a massive reduction of compressor fouling is 14 times higher. And another point here to mention is we have pretty much now stabilized pressure drop levels. That means the final filter achieves now 3 years service life against 1 year service life of the original system, and the pre-filters and the intermediate filter achieve also now 1 year service life against less than 1 year with the old filter system. So pretty much the operation is stabilized, surplus that we can say that the unit with the EMW's filters saved the operator round about $800,000, and all 3 units are now in operation with EMW's filter upgrade. And very important, the entire upgrade was integrated without a change on the filter house design. So there we are, there's the treasure. I would love to take it back home, but that's the treasure of our customer. And if we should find your treasure at your site, please feel free to contact us. And then I would say, if you want to stay tuned, just join us on LinkedIn, on YouTube, etc. And then we're gonna see you next time. Toll.